stats video. Hope everybody is enjoying their evening. Just wanted to record part 6C through F. So part 6C said let X represent the number of consumers who prefer citrus fresh. So they have a little table here. Assuming there's no difference in consumer preference, find the probability for each possible value of X. Record the values below. Okay. So X and the probability of X. So if you think about it, they've asked 8 people, so 8 equals n. So the possible values for X are 0 people could like citrus, 1, 2, 3, 4, 5, 6, 7, let me zoom out a little bit, and 8. These are the different probabilities of people who could like citrus. And the question is, we need to fill in a table, right? There can't be more than 8 people who like this because there's only 8, and there can't be less than 0. So we need to find the probability for each one. So the probability that 0 people like citrus, if you really think about this, this is a binomial setting. Why is it binomial? Because it meets the 4 binomial conditions. 1, fixed number of trials, 8. Number 2, everything is either a success or a failure. Either people like citrus or they don't. Number 3, probability of success is constant. We are always at 0.5 every single time. Right? And number 4, each trial is independent. And that's true. What one customer thinks does not affect what another customer thinks. We assume each customer's preferences are independent. This is a case of binomial. So using binomial, how many people want, or what's the probability of preferring 0 citrus? Well, remember binomial. You got to look back at your chart. They give me the binomial formula right here. nk, p to the k, 1 minus p to the n minus k. So 8, 0, p is 0.5 to the 0 power, times 1 minus 0.5 to the 8th power. And if I do that on my calculator, remember this is the combination button, 0.5 to 0 power, blah, 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 we get 0.00391. Now what about here? Well, this is 8, 1, 0.5 to the 1st power, 1 minus 0.5 to the 7th power. And we get 0.03125. Now what about number 2? Well, here it is 8, 2, 0.5 to the 2nd power. Why second? Because we're saying the probability that x equals 2. This is the probability x equals 0, x equals 1, x equals 2, x equals 3, x equals 4, x equals 5, x equals 6, x equals 7, x equals 8. And then 1 minus 0.5 to the 6th. And I'll get 0.10937. This is 0.21875. 0.27344. I would just go through and do this for every single one. Okay, so that is part C. Right? Filling in the table using binomial CDF. Now let's see what they asked on part D. On part D, it says when testing the hypotheses in part A, Sunshine Farms will conclude that there is a consumer preference if too many or too few individuals prefer citrus fresh. Based on the probabilities in part C, is it possible for the significance level for this test to be exactly 0.5? In other words, could the p-value equal 0.05? That's the question. Well, here are the p-values. And there's no way that when adding these p-values up, you could ever get 0.5, right? This plus this alone, too small. This plus this does not equal 0.05. And if you add this in, we're too big. So this is no. Because, I'll go to the next page. So on part D, the answer is no. Because the simulated, that's what we found, probabilities, can never sum to 0.05. Probability x equals 0 is 0.00391. Probability x equals 1 is 0.03125. These are too small. And adding probability x equals 2, 0.10937 is too big. Alright. Now what about level E? Part E says the preference data for 8 customers are given below. Okay? So the p-value we get is 2 out of 8, right? That's the number who prefers citrus, which is equal to 0.25. And they say based on this, test the hypotheses in part A. So in part A, our hypothesis was p equals 0.5, and the alternative, p does not equal 0.5. So let's see. The probability p equals 0.25 is what? In other words, that's the probability x equals 2 plus x equals 1 plus x equals 0. If you think about, here's 2. Sorry, this is the wrong picture. So to think about the picture here, right? The picture is the following, right? So the p citrus equals 0.25. The p-value is equal to the probability x equals 0 plus the probability x equals 1 plus the probability x equals 2. So if you think about a picture, here's 4, this was the average, so we're here at 2. So we're taking this probability, right? And because this is a double-sided test, right? Because this is a two-sided test, right? The null was PC equals 0.5, and the alternative was PC does not equal 0.5, right? Because it's a two-sided test, I need to find this probability. So this is P x equals 0 plus Px equals 1 plus Px equals 2. And then I need to double this because this is a does not equal, so it's actually a double-sided test. Double this because we have a double-sided test. So what is this equal to? Well, this is probability of 0 plus 1 plus 2. So that's 0.10937 plus 0.03125. So to get this, we'll go on the next page, right? So we're saying probability of x equals 0. Right, so this is 0.00391 plus the probability x equals 1, which is 0.03125 plus probability x equals 2, which is 0.10937. This gives you 0.14453. Then you need to take this and actually multiply it by 2. Why multiply it by 2? Because you have a double-sided test, right? A does not equal, which means you're doing a double-sided. Multiply this by 2. And your p-value equals 0.28906, which is greater than 0.05. So therefore, in answer to the question, we fail to reject the null because the p-value greater than 0.05. We conclude preferences are not significantly different. Preferences are not significantly different. All right. And finally on part F, if they want to redo it, how could they make it better? Well, I would increase the sample size. So therefore you have more measurements and thus the z-stat, which remember z-stat would be equal to p minus p hat all over square root of pq over n. Z-stat will increase and p-value will fall. If the z-stat goes up, right, the p-value has to fall, which will allow me to have a more robust statistical test. Increasing the sample size makes the z-stat go up. This gets bigger, right? This gets smaller. Dividing by a smaller number makes this go bigger, and therefore the p-value goes down, which means my statistical test is stronger. Or maybe, if you want to say it differently, the power is greater. Remember, power goes up as we increase the sample size. Hope this video was helpful. Let me know how I can be more helpful.